Hi guys, welcome back to my YouTube channel. In this video, we'll be going over a few practice questions for the straight lines topic that we did in the last video. I hope you guys stick around and I hope you enjoyed this video. Let's begin. Okay, so here we have the first question. I'll just change the pen color real quick. Okay, so we have a straight line that passes through the points -1, 3 and 11, 12. I'll just write that down again. So -1, 3 and 11, 12. So we have a line that passes through these 2 points here. And now we have to find an equation for the line that passes through these 2 points in the form ax plus by equals c. Now, if you remember from the last video, this form here, ax plus by plus c equals 0, well, it's close to the general form because the general form is written in the form ax plus by equals d. This is the general form. And here we have something really similar to the general form. But it would be super easy to convert from the general form to this form here by subtracting d from both sides. So if we subtract d from here and we subtract d from here, you get ax plus by minus d equals 0. Now, of course, d and c are just constants that can be represented by any number, so it doesn't really matter what symbol we use here. So now let's start solving. Okay, so firstly we need to find the equation. For this equation, the first thing we need is the gradient. The gradient, which we're going to be representing using the letter m. That is the standard. You usually represent gradients using the letter m. So the gradient of m of line L1 is the change in y divided by the change in x. And here the change in y is 12 subtracted by 3 divided by 11 subtracted by -1. And that just equals to, so 12 minus 3 is 9, divided by, and of course 11 minus -1 is just the same thing as 11 plus 1, which is 12. 9 by 12, which then simplifies to 3 divided by 4. So now we have the gradient equal to, so here I'll write it again. So the gradient of line L1 is equal to 3 divided by 4, 3/4, or 0.75. Now we have this, we can easily, okay, we have the gradient and we have 2 points. Here we can take 2 paths forward, trying to find the equation for L1. Firstly, we could just use the point gradient form, which is written in this form, y minus y1 equals m x minus x1. And here this form would actually be easier for us to work with right now because we have the gradient here, which we can plug in to this value, and we have 2 points that we can move forward with, finding their respective x coordinates and y coordinates. So for x1 we could just use -1, and for y1 we could just use 3. So if I write this down here, this becomes the coordinate that we will use for the x1 value and the y1 value here. So moving forward, y minus y1, I'll just draw a line here and start again. Y minus y1, which is 3, equals m, which is the gradient, 3 by 4 multiplied by x minus x1. So x minus -1. Okay, just made it. And now if we were to simplify this down, y minus 3 equals 3 divided by 4 times x plus 1, because a negative number being subtracted by something is the same thing as adding that number onto the something. And then we just have to solve this a bit further. Y minus 3 equals, so here we multiply 3 by 4 to x and to 1. So 3 by 4x plus 3 over 4. And I'll just move this up here. And now we have x and we have y, and we can just bring all of them on one side. We can, okay, so x here is being divided by 4, so 3 divided by 4, x plus 3 by 4 equals y minus 3. We need to get rid of the fractions here so that everything ends up in being in this form up here. So we can multiply everything here by 4. So it would be 4 multiplied by y minus 3 equals 3 by 4x. Oh, that's an x, my bad. X plus 3 by 4. And now that just equals 4 times y, 4y, 4 times 3 minus 12 equals, now 4 times 3 divided by 4 is just 3x. And then here it would be a 3 again because the 4's cancel out. Plus 3. Now we can just rearrange. So this becomes 4y minus 3x. And here, because we subtracted 3 from both sides, 3x from both sides, and now we have a minus 12 here, and we have a positive 3 here. So if we just subtract minus 3 from both sides, if we subtract 3 from both sides, this becomes a minus 15, and then we are left with a 0 here. Minus 15 equals 0. And now we have this equation in the form ax, not yet. We have to change the order around a bit. So it becomes minus 3x plus 4y minus 15 equals 0. And now we have it in the form ax plus by plus c, where a, b, c are integers. So negative 3 is an integer, 4 is an integer, and negative 15 is an integer. And that is why we could not use the fractions down here. Okay, so now moving on to the next part. Okay, so for the next part of the question, it says that we have a line L2 that has the equation 3y plus 4x minus 30 equals 0. And we have to find the coordinate of the point of intersection between L1 and L2. So if I rewrite it here, L1 has the equation 4y minus 3x minus 15 equals 0. And now here you might see that the order is different, but that really does not make a difference because whenever we put the value of x and y in here, it will always give the same answer. And then L2 has the equation 3y plus 4x minus 30 equals 0. And now if you pay close attention here, you might see that these two equations are actually simultaneous equations. So now for L1, if we just add 15 to both sides, we get 4y minus 3x equals 15, because we added 15 to both sides. Now for the equation L2, if we add 30 to both sides, we get 3y plus 4x equals 30. So now we have two simultaneous equations here, and we can solve them ourselves. I'll just change the pen color here real quick. Okay, so let's solve these equations. Now firstly, what we can solve these equations using substitution. or we can actually add these simultaneous equations together. So I personally prefer adding them together. I'll demonstrate what I mean through this question. But the other way through substitution is to first rearrange this equation here to give a value for x, and then plugging that value of x into this second equation here to give you a value for y. That is basically how you would solve this equation using substitution. But I really don't like that method, and I personally prefer the other method that I'm going to show you now. So for solving simultaneous equations, what I do is I try to get one of the variables in both the equations to have the same coefficient. And by coefficient, I mean the number in front. So if I choose the variable y, then I need to make sure that in both of these equations, the number in front of y, its coefficient, should be the same. Now 4 and 3. For the coefficient of y to be the same for both of these equations, I need to multiply this entire equation up here by 3. And for this equation here, its coefficient of y to equal the coefficient of y of this equation, I need to multiply this equation by 4. And if I just do that down here, so 4y times 3 is just 12y minus 3 times 3 is 9x equals, and 15 times 3 is 45. And down here, I'll do the same thing. 3 times 4 is 12, so 12y plus 4 times 4 is 16, and 30 times 4 is 120. So now here we have a simultaneous equation in which the coefficients of the y variables are the same. And now I'll just multiply one of the equations by -1. I'll multiply this equation by -1, and that basically has the effect of flipping the signs, so that it would become -12y plus 9x equals -45. 45. And now what I can do is, if I just write the other equation down here as well, 12y plus 16x equals 120. And now if I add these two together here, these two can, the values of y can just cross out. These two just cross out. And then I can just add the x values together and the right-hand side values together to give me an equation in x. I'll just change the color again. So here, 9 plus 16 is 25. So 25x equals 120 minus 45. And that gives us 75. And now if we just divide both of these sides by 25, we get x equals 75 divided by 25 is 3. So now we have a value of x. And what we just do now is that we substitute this value of x into any one of those two equations we came up with before, which are these ones down here. So now if we substitute in the value of x here, so x is 3, so 3y plus 4x equals 30. We put x as 3, so 3y plus 4 times 3. 4 times 3 is 12, so 3y plus 12 equals 30. 3y equals 30 minus 12, because we subtract 12 from both sides, and that gives us 18. And then dividing both sides by 3 gives us y as 6. So now we have a value of x, 3, and a value of y, 6. And that is actually the coordinate of the point of intersection of L1 and L2. And so that means that L1 equaled L2, where x equals 3 and y equals 6. So that would be the coordinate 3, 6. L1 equals L2 at this coordinate. This is the point of intersection for L1 and L2. Okay, so this is how you would solve this question over here. I have put some more questions linked in the description below, so I would recommend that you go over those questions and try to solve them yourselves. If you have any trouble solving those questions, then please feel free to leave a comment down below, and I will make sure to address it in the next video. Thank you for watching this video, and I hope you enjoyed it. Thank you.